Hello, and welcome to Let's Meet the Virologists, a podcast about the people behind today's virology headlines, people just like you working to understand viruses and how they affect you. During the COVID-19 pandemic, we are talking with postdoctoral researchers involved in coronavirus and COVID-19 related research so that you can learn who they are and what they do. I am Larissa Backray, and I am hosting this podcast from America's Heartland in St. Louis, Missouri. 2 monoclonal antibody treatments for SARS-CoV-2 infection have recently received emergency use authorization from the FDA, and others are currently being evaluated in clinical trials. Early results show that monoclonal antibodies may reduce hospitalizations by up to 70% if they are taken early enough in the course of infection. Their use in an outpatient setting is currently being encouraged for high-risk patients. On November 30th, 2020, we talked with Dr. Brett Case, a postdoc in the Diamond Lab at Washington University School of Medicine, who has been characterizing many monoclonal antibodies for SARS-CoV-2. Brett received his PhD in microbiology and immunology at Vanderbilt University, where he studied coronaviruses. In the Diamond Lab, his focus has been on IFID-mediated restriction of flaviviruses and now antibody-mediated protection for SARS-CoV-2. Hi, Brett. I'm happy to have you with us today. Why don't you tell us a little bit about yourself? How did you become interested in virology research?
Hey, Larissa, thanks for having me. I got interested in virology research, I guess, early on in grad school. You're doing your rotations, you're trying to find a lab that you're interested in joining. And I started out recovering a few mutant viruses in Mark Dennison's lab at Vanderbilt. And you go from assembling all these different components using a reverse genetic system in a manner that really seems like it shouldn't and wouldn't work. But then you electroporate everything into cells, and then the next day you go and you look at the flask under the microscope and you see CPE there, and it's like, wow, that's cool. And so that was certainly the moment, I guess, where I was really interested in viruses and how they worked and things like that, on top of what I was already interested in, being kind of virology, immunology as it is anyway. So, yeah.
What about sort of in high school or earlier on? Were you exposed to science in a way that sort of led you down that path, or was it just in graduate school?
So certainly viruses have I guess, always been interesting to me, but in college, I really got on track with regard to science and academic research and things like that. But it wasn't until graduate school that I really was exposed to viruses and virus research. So yeah, I guess it was graduate school.
Can you describe in a little bit more detail sort of some of the steps you took to get to sort of your graduate lab and then your postdoc lab? So how did you sort of choose those labs?
For me, I started out at the University of Tennessee on a kind of a pre-med track, declared a major in biochemistry and cellular and molecular biology. And one of the things that they offer, of course, is for you to do some coursework in a research lab for credit. And of course, then you get your hands wet, you get exposed to specifically whatever that lab is working on. And so I got started, there was a lab that had just started, Brad Bender, studying the ethylene signaling processes in plants. And this was, very new to me and very interesting. And so you turn ethylene gas on in a seed that is germinating, and, do time-lapse photography and see exactly how the effects of the concentration of ethylene, the amount of ethylene, the time that it's on, and all of those things alter germination kinetics and just overall the processes that are occurring to keep it light. And so that got me exposed to research. Upon graduating from Tennessee, I knew that I still wanted to stay in research. And so I took a couple years and worked in a research lab at Vanderbilt. At the time, Peggy Kendall was at Vanderbilt, and funny story is that she's actually now at WashU. So I guess she's following me now instead of me following her. But anyway, studying type 1 diabetes in the context of B cell contributions of B cell and T cells in NOD mice. And so that was a good couple years to really get deep into immunology research, mouse research, and of course, more full-time research than just working part-time in a lab. After a couple of years there, I knew that I really wanted to go to graduate school, and so I applied to several places and ended up just staying at Vanderbilt and stayed in the same Department of Microbiology and Immunology, and ended up joining Mark Dennison's lab, as already mentioned, and studied coronaviruses for 5.5 years.
And how did you choose Mark's lab? Like, what was it that sort of led you to choose that particular lab?
Yeah, so like I kind of already mentioned about how it was really, I guess, like, oh wow kind of moment, with regard to viruses. But also, I mean, there are many great labs at Vanderbilt in that department. And for whatever reason, it's a combination of the science, the mentor, the people in the lab, the resources, things like that, and it felt right. I was very interested in coronaviruses at the time. MERS was just emerging and things like that, so it was certainly a combination of things.
Why don't you tell us, since we're on coronaviruses, why don't you tell us a little bit about some of the COVID SARS-CoV-2 research that you've been working on? I know you've done a lot of work with antibodies, so can you describe some of that work?
Yeah, so how much time do we have? The last 10 months have been crazy. As far as antibodies, we've worked with several different groups, including the Crow Lab from Vanderbilt, Veer Biotechnology. We have some, you can't really call them antibodies, but they're more like tiny peptides that bind specifically the RBD portion of spike from the Baker Lab, the University of Washington. And there are several other groups that I'm not even mentioning here, but we've really done a little bit of it all from the standpoint of we've done, as you've been a part of large scale screens to identify antibodies. We've put several of those that we found into mice. So there's the aspect of developing the mouse models. We have developed assays to actually verify, validate all of those kind of screening hits. We've looked specifically at receptor binding domain antibodies. We have a few N-terminal domain antibodies. We've done IgG antibodies primarily, but we've also looked at some IgA, some IgG, IgA chimeras. We've really touched a little bit of everything. And of course, very few of those we actually have structure on or really know how exactly they work. We're only beginning to understand the contributions of effector functions for these, some of the just a small subset of antibodies. And so primarily I've been involved with, identification, validation with newt assays, and then also putting those into mice to see whether they can protect as a prophylactic or if they can protect as a therapy. And if they can, of course, how far out before exposure or after exposure can we go and still see protection? And so that's kind of the 40,000 foot view, I guess.
Can you give us some thoughts about, some of these are now in clinical trials, some even getting into phase 3 clinical trials. What are your thoughts about when a monoclonal antibody might be the most effective, or whether they can be used sort of later on in disease or not? What do you think?
Yeah, so I haven't seen a lot of the clinical trial data yet, but just based on our research, I would say there's a therapeutic window of a few days in mice, which may be even longer in humans, and certainly with repeated doses. And I think that we have so many antibodies that bind in such different regions that really there's no reason why we couldn't have several different cocktails of antibodies. So then the resistance mutations arising, that becomes less of an issue and a worry, as well as there's no shortage of the numbers that we could try, right? That may help in some capacity. So I'm optimistic about using them. Of course, the vaccines are coming online a little bit, it seems like shortly, but I still think that there will be a use for the antibodies, of course, that we've been developing. And certainly there's only so many doses of vaccine that can be generated and distributed and administered. And, even then after you've received the vaccine, it's going to take a little time to have a response to it. So I think antibodies certainly have the capacity to help and assist where vaccines are not present yet, as well as maybe treat after the fact.
Do you think from the mouse work that there's a chance that different classes or different mechanisms of antibodies will allow some of them to be used sort of later in later stages of infection? Or is it pretty much all just like dealing with virus load in a way?
So in my experience, I think it has more to do with virus load initially and neutralization of virus, which of course then has downstream effects on the amount of actual virus, the MOI, the effective MOI that you actually receive, as well as then the subsequent immune response to that infection. So that's my experience. I'm sure that there are antibodies that are out there that could have bigger effects than that, and maybe further out. But at least in my work, I think we're talking about neutralizing antibodies very early on, affecting viral load, and then, like I said, subsequent immune response.
I guess just a follow-up question. So since you had worked on MERS and some of these other coronaviruses, did you ever expect to be working on coronavirus in the context of a pandemic?
Absolutely not. So it's one of those things that as you're writing grants or writing papers, that the fact that SARS emerged and no one saw that coming, and then MERS emerged and no one saw that coming, and there's continued, exposure between bats, which of course are just humongous reservoirs for coronaviruses and other viruses too. We always say that another virus could emerge, and it is likely, and it's true, but I don't think we ever could have imagined it would be in this kind of context, and that there would be a not just an epidemic or an outbreak, but a pandemic, and not just a pandemic of thousands of cases, but rather millions and millions of cases. And so I certainly had aspirations of working on coronaviruses again one day. When I started a postdoc, and maybe not quite as soon as I have. So yeah, it's been crazy.
You talked a little bit about that sort of exciting moment where you discovered sort of recombinant viruses in a way. What is the most difficult thing you've had to overcome as a scientist, and how did you overcome it?
Yeah, so this is maybe a little bit different than a typical response to this question might be, but my primary, I guess, difficulties in science have been just the physical and mental aspects of it. And what I mean by that is being a virologist, we spend, there are very few things that you can do not in a biosafety cabinet. And being physically stretched out into a biosafety cabinet for hours upon hours, days upon days, weeks upon weeks, years after years, it takes a toll on you. And certainly then also just, I think the way that I am programmed is to be very stressed and very worried about things. And science leaves plenty of opportunity for all of those things, just purely on the basis of trying to get things done in a timely manner, manage, what you have going and keep everything straight, let alone just, will this experiment work? Does this make sense? What does it mean? I don't know. So those have been my two main things to overcome in science, and that may be true for any career that I could have picked, but certainly that's been my experience. And as far as overcoming them, I certainly can't say that I have overcome them, but I think I've learned to manage them, and manage them meaning, physical therapy exercises for the physical aspects, and just mental health, stress relief things for the mental aspects. So kind of different, but certainly that's been my biggest challenge.
So for the mental health stuff, I mean, that must have gotten even worse in the past 10 months. So how have you been coping with the stress? Because it's not just the stress of the job, it's like the stress of the world in a way. So how have you been dealing with that?
To a certain degree, it's gotten better and it's gotten worse, and I'll explain both. So it's gotten worse, and you're right. There's people pulling at you from all different directions, needing and wanting and not sure about things, and that goes from career wise and science wise to family, asking questions and spouse, asking questions, things like that. So certainly there has been more stress from just the overall amount of work and constantly my brain being on in the last 10 months than I've ever experienced. But at the same time, I feel, we always, I guess in science, there are many questions that we can ask, and a lot of times they are all very important, but some have more immediate impact and are more translatable and arguably more important than others. And I think in the last 10 months, I haven't had to worry about any of that, whether this experiment is really worth doing or not. It's very, yes, go. And so, and of course, we've had a lot of productivity with regard to SARS-CoV-2. And so for me, seeing, things start out, the first injection of a mouse with something, or, the first isolation of an antibody to actually injecting a mouse with it and seeing protection from start to finish has been very gratifying to actually see, okay, that we're making progress, we're doing things that are potentially beneficial to a large number of people, not just us in a science bubble.
So what's next? What do you think? How do you see your path sort of moving forward?
Yeah, so I think my path moving forward is progressing. Certainly, I've had a ton of publications, from SARS-CoV-2 work. Still have some of my original work that I need to finish up if I ever get an opportunity to get out. But overall, I think that my goals are to try to get this, to continue to work on SARS-CoV-2 and to get the pandemic under control from that standpoint. And then after that, really try to take the opportunity to develop my own, research projects and plans and what I really am interested in, so where I can, and of course, establish my own lab someday in a timely manner and start off on a good foot with some SARS-CoV-2 work, but also some non-SARS-CoV-2 work. So that's where I see myself in the next year to 2 years of really eventually transitioning to more than just SARS-CoV-2, but at the same time trying to be a little bit more independent minded.
So I guess moving to the personal thing, how has the COVID-19 pandemic affected you as an individual? So what's changed for you over the past 10 months?
The biggest change, and this is not to be in any way boastful, but I have no free time. I work more than I've ever worked, in my life, and maybe in the past I would work really hard and work on weekends and things like that, but now that this has been even beyond anything in the past. So very few days of actual time away, and certainly come home at night and it's not just, okay, I went to work and I worked. It's their emails, papers, reviews. There's any number of things that keep me busy into the night, and that's all day every day. So that's the biggest thing, I think, that I've had very little downtime for myself and for others. And to a certain degree, I feel like it's warranted, and to a certain degree, maybe I should take it easy a little bit, but right now is not the time. So
do you take some downtime though to kind of cope? Is there something that you do to sort of manage, or do you just work constantly and sleep?
To be completely honest, very little downtime. I'm constantly doing something, and at first I thought, okay, I'm okay, I can push through, keep my head down, keep going. And certainly to this point now, the pandemic continues to go on. I keep thinking, okay, another month or two and things will be better, another month or two and things will be better. And here we are, who knows when. So at a certain point, I definitely will have to take a small break. But right now, I think that mentally I see that there's only one way, and that is just keep pushing. So that's what I'm doing. And so far I haven't cracked yet. So we'll keep it up as long as I can.
So I guess maybe this is less of a question for you because you're just working. But as a virologist, how do you make decisions about how to keep yourself and your family safe during the pandemic?
WashU has done a good job with providing information, with regard to safe work practices that could then also be extended to your home and yourself. And of course, Mike has pushed for safety for us as a lab. And so it's very easy to take a lot of those practices and just convey them to others in your family and the way that you work and things like that, things that you do outside of work. And of course, to a large extent, the pandemic has caused a lot of closures and a lot of altered hours and things like that. So to a certain degree, there's limited capacity to actually do anything anyway, but certainly if you're working a lot. And so I think the main things I've tried to do is just actually share information with my wife as well as my family. Not just, hey, do this because someone said so, but here's why and here's how. And there's a lot of misinformation and a lot of exaggeration and a lot of just overall unknowns with regard to information that's been going on, across the entire pandemic. And so I think being a coronavirologist, actually working with the virus on a daily basis, I'd like to think they take my word for it a little bit more than maybe the TV. And so, I just try to let them understand, show them and teach them and help them understand what and why versus just here's what someone said do. And so and of course, as this is continuing on, there's also been more and more data. And so then I can take something that someone either wants me to look at or that I find, and I can actually assess it for, is this actually a good study? Was this thorough? Was this, does this make any sense? And, from the field, and I can then, render an opinion on it, or recommendation or not, for them.
And we are hearing reports, obviously, that vaccines will be coming soon. It's obviously not clear when when the vaccines will be available and so on. What are your thoughts about the vaccines themselves?
My thoughts on the vaccines, I guess, would be hopefully production can keep up with demand. And what I mean by that, obviously, everyone needs one or wants one right now, but I think if there is a planned rollout of the vaccines, it needs to also not just be here's wishful thinking of how fast it needs to actually be practical. And so that if you say in February we're going to have 100,000 people have been vaccinated, you need to deliver on that, because if things start, if the pandemic is still going and you have vaccines not making it when they're supposed to be, then you're going to have people getting further stressed about it and worried about it. I also think that the safety, aspect of it with regard to the vaccines, obviously they've been through clinical trials. Hopefully there are no surprises, and there isn't anything that completely makes the world lose faith in scientists, because even as thorough as you can be and as good as you can try to be to prevent adverse events, sometimes it happens. And I don't think that's the case for any of these vaccines. I'm just saying that God help us if it does, because, it's just going to make things even worse.
So we're wrapping up. Any last messages for our listeners? Any thoughts about where you see the COVID-19 pandemic going?
Yeah, I guess any final thoughts would be just hang in there and stay with it. We've done it for this long. We know what to do and how to do it. So just keep on keeping on, I guess. As far as the overall pandemic, I think we're getting to that point where it's actually, all of this work that's been going around the world by numerous people is actually, going to have to start showing up, not just in scientific publications or on the news. We're actually going to see a difference made. And so I'm excited for it. But at the same time, I think, we have to be patient still and stay, with Thanksgiving just passed and Christmas coming up, I'm afraid that the worst still may be to come in some aspects. So I think we're definitely getting to a climax here. So let's see if we can have a good ending.
All right. Well, thanks very much. Brett and many others around the world have been working hard over the past 10 months to identify and characterize monoclonal antibodies against SARS-CoV-2, several of which are currently available to prevent or treat COVID in high-risk patient populations. This has been Let's Meet the Virologists, a podcast about people who study viruses. This is your host, Larissa Thackeray, and thanks for listening. You can find us on most podcasts or at LMtVpodbean.com. If you are a virologist interested in sharing who you are and what you do, please contact us at letusmeetthevirologists@gmail.com.